All right. Okay, we're good. Okay, 5.5, solving rational inequalities. So same as solving equations, except there's an inequality sign. So there's one rule that we have to make sure that we take into account, that we don't have to take into account with an equation, and that is bringing something over the inequality sign. And that's because we don't know the value of x, I can't multiply this side by x to move it. Because if x was negative, it would change the sign. So because I don't know that, I can't do that. So what I'm going to do instead is I'm going to bring over the entire 8 over x. And now I have a 0 on one side. So step one, when you solve rational inequalities, bring everything over to one side. Pretty easy. Your second step is generally always add or subtract. There's going to be a bunch of fractions here. You have to know how to add and subtract fractions that have variables and numbers. So over here, I know my common denominator is going to be x. So everything over here needs to take an x. So I'll show you that second step if you really want to see it like this. You don't really need to see that step, but that's how you add fractions with a common denominator of x. So they all have x. Now I can change this to everything over x. Okay, I have no idea where the x-intercepts are, where the asymptotes are technically, until I'm all factored, even though you can argue that you already know the denominator asymptote. So I'm going to factor this numerator. Okay, how do I factor x squared minus 2x minus 8? X minus 4, x plus 2, over x less than 0. So this is the best form when I'm solving rational inequalities. From here, I find all my answers. And I can find all my answers using a decision table, which I don't do. I don't like decision tables, they take too long. If you know how to graph polynomial equations, this is the best strategy to graph this. So what do I mean by that? Take a look at this entire thing. How many degrees are here in total? 1, 2, 3. Positive leading coefficient. So if I have to graph this like this, there's a x-intercept at 4, at -2, and at 0. This is not how this graph looks for this function. This is not how it looks. But if you use this strategy to understand positive and negative intervals, you can answer this question, because this is asking when is it less than 0? When is it below the x-axis? So I go like this. I know it's a odd function with a positive leading coefficient to the exponent 3. And now I can answer this question of when it's less than 0. Well, it's less than 0. Let me actually label these so I can not make a mistake. It's less than 0 from -infinity to -2. And it's less than 0 from 0 to 4. Done. That's it. Okay? With a quick graph and understanding end behavior and turning points and x-intercepts, you can quickly come up with the answer, which is -infinity to -2 if you're using interval notation, and 0 to 4. Or if you want to use set notation, x is less than -2, and x is between 0 and 4. Okay, whatever form you want to use. For inequalities, your answers will always be in terms of some sort of interval or intervals, 2 intervals, 3 intervals, 1 interval, whatever the case may be. Okay, let's take a look at a little more complicated one. Okay, not too complicated, but again, I can't cross multiply the x minus 3 and the x plus 1, so I have to bring over the entire fraction. And this is greater than or equal to 0. Now that I have this, I can cross multiply to add these fractions, because I know my denominator is going to have both of these, one of each factor. So this is this times this, which I'm going to go right into difference of squares and solve that, because I see that. And I'm going to have minus, and I'm going to open brackets because I always do that after I draw minus sign. And I can multiply these at the same time too. X minus 2 times x plus 1 is x squared minus x minus 2. All over x plus 1, x minus 3. Okay, every line should be correct. Greater than or equal to 0. Okay, now from here, I'm going to drop the brackets and simplify the numerator. So this is x squared minus x squared. See you later. This is a positive x. And a -9 minus -2 is a -7. If you're confused about this guy right here, let's take a look over here. X minus 2, x plus 1, we get x squared plus x, negative 2x minus 2, x squared minus x minus 2. Okay, you shouldn't have to do it that way, but if you have to, you have to. Okay, so now we're fully simplified, we're fully factored. I can draw a little graph. At positive 7, I'm going to put an x-intercept. Okay. At negative 1, I'm going to put an x-intercept. Now, there's no x-intercept at negative 1 for this function. Okay, that's not what we're doing here. Just this is a strategy to help us with positive and negative intervals. I can't say that enough because it's going to confuse you. And at 3. 1, 2, 3 degrees, that's positive. Done. When is it greater than or equal to 0? Between negative 1 and 3 and after 7. So I can answer this question saying when it's between negative 1 and 3 and when x is greater than or equal to 7. It is greater than 0 here, it is greater than 0 here. This is not the graph of this reciprocal function or this rational function, but it helps to understand positive and negative intervals to draw the graph like we did in chapter 3.